Okay, today's Friday, and I will be back Monday to hopefully answer any questions that you didn't get answered, but we're going to go ahead with section 2.5, zeros of polynomial functions. Okay, so what we're going to do is we're going to use several different concepts. This is pretty new, so a lot of this you'll have to really pay attention to and take some very, very good notes on. Again, this will be in at least 2 parts, maybe 3, depending on how long it takes. First of all, we know that the fundamental theorem of algebra is basically the highest power of our polynomial tells us how many zeros we're going to have. Okay, so if I were to give you f of x equals x minus 2, okay, well that's just linear. That's just linear. It's to the first power, so it's going to have one root or 1 0. It's going to cross the x-axis one time. If I were to give you this quadratic right here, x squared minus 6x plus 9. Well, that highest power is a 2, so that you know you're going to have 2 zeros. And in this case, it happens to be a double root, but you're going to still have 2 zeros. If I give you this, f of x equals x cubed plus 4x, well, you know that you're going to have a total of 3 zeros. Okay, now for this, we would have to say, well, how would we get that? Let's factor out an x, and that'd leave us with x squared plus 4. Okay, so to set each one of those equal to 0, we put here the x times x squared plus 4. Okay, well, you know that x is equal to 0, but look here, x squared plus 4 equals 0. Now, when we get ready to solve that, that's going to be a little bit different. Move that 4 over, x squared equals negative 4, and then we're going to square root each side. So we know that x is equal to plus or minus 2i, because that was our last section, was the complex number. So there's our total of 3 roots. There's one of them, and here's the other 2. Okay? So we're going to be using the complex number concept as well. Now, here's another one. Let's say we have x to the 4th minus 1, and we want to know how many zeros we're going to have. Well, you know that we're going to have 4. That's a difference of 2 squares, so we could have x squared minus 1 times x squared plus 1. Well, we've got to set each one of those equal to 0, but this one's not factored. That can go again. Difference of squares again. X minus 1, x plus 1. And x squared plus 1 does not factor because it's not a difference. Now you set each one of those equal to 0, so x equals 1 is a 0. X equals negative 1 is a 0. And what about this one? X squared equals negative 1. When you square root each side, then x is equal to plus or minus I. So there's our 4 roots. 1, 2, and that counts as 2, 3, 4. So that's one of the things that we're going to be looking at is just that fundamental theorem of algebra where you look and you decide how many solutions am I going to have, and then you work until you get all of those. Now, there is a rational zero test that tells you possible zeros, but I'm not going to make you do that, and you can thank me for that later because it's a little bit involved. What I'm going to do is I'm either going to give you a 0 to get you started, or I'll allow you to get it out of the calculator, okay? You can go to the calculator and use your table, and anywhere you see y equal to 0, you can use one of those. Even though you may find all of them in the calculator, I'm not going to let you do that. I'm going to make you get one out of the calculator and then work to find the rest of them. Okay, so here's our first example. Okay, here's our function, and it's 2x cubed plus 3x squared minus 8x plus 3. Okay, now what we're wanting to do is to find all the zeros of this polynomial. You can tell we're supposed to have 3 of them, okay? But that's not going to factor. You can't group that, so you're kind of stuck. So what you're going to do is you're going to check the calculator, and you're going to get 1 0 out of the calculator. Okay, now if you type that into y equals, you can get 1 out of the table, and I'm going to let you use 1 as a 0. And you can see if you were to type that in the calculator, that's what you would get. Now we're going to use our synthetic division that we did a few sections ago, so don't forget anything you know. You know how that goes in algebra. You have to remember it all, and then more so even in pre-cal. So I'm going to use this as a 0, and we know if it's a 0, it was a factor, so we should come out with a 0 remainder down here at the very end. So bring your 2 down, and then you multiply, add those together, and then you multiply, add those together, and then you multiply. So you can see that it was a 0. That comes out to no remainder. So remember, we write our polynomial, our final answer, starting with 1 power less. So since it was cubed, we start with 1 power less. 2x squared plus 5x minus 3. And we're going to go ahead and say that's the polynomial. We've got to find how many more zeros for. I let you get 1 out of the calculator. Aren't we still looking for 2 more? So what we're going to do is we're just going to factor that. So we're getting into a situation that using synthetic division helped us be able to factor. So I'm using bottoms up right here. Don't forget your 2 over there. X and X. The factors of 6 that subtract and give us 5 are 6 and 1. Okay, the signs are different. The big one gets the plus. And then we want to put that 2 underneath. Okay, so you know that we have factors of x plus 3 and 2x minus 1. X plus 3 and 2x minus 1. Okay, so now we can easily find the zeros. The 0 for this one is negative 3. And the 0 for this one right over here is 1/2. Okay, and we started out with the given 0 of 1. So that's our intercepts right there. Negative 3, 0. 1/2, 0. And 1, 0. And we got one of those out of the calculator, and that was this one. And then we use synthetic division to find those two. So that's one of the ways that we can use synthetic division to help us find all the zeros of a higher degree polynomial. Now, I'm not making you do the rational zero test. Of course, I told you about that. I'm letting you get one out of the calculator. I'm going to try to explain that to you when I get back. All right? Okay, so that takes care of having a polynomial that you need to find zeros of that you cannot factor. You can't use a quadratic formula on it because it's not a quadratic. So you get 1 0 out of the calculator, and then you use synthetic division. And if one set of synthetic division won't get you down to a factorable polynomial, then you just go again until you get it down to something that will factor. You can continue getting zeros out of the calculator until you get it down to something that you can factor. If you can factor it with a power of 3, then factor it, because factoring is always easiest. But that's the concept. Okay, now then we're going to go ahead and we're going to talk about how every time that you have a complex 0, it always occurs in a conjugate pair. Okay, so this is a star that you're going to want to put in your notes. Okay, so complex zeros always occur in conjugate pairs. Okay, now we've already learned what a conjugate pair is. A plus bi, a minus bi. 4 plus 3i, 4 minus 3i. Those are conjugate pairs. So when you see that you have a complex 0, you know that there's another 0 that was its conjugate that was also a part of that polynomial. So you have to remember that to be able to solve these. Now what I'm going to do is I'm going to ask you to use this concept, and you are going to do the following, okay? You're going to find a 4th degree, that means to the 4th power, 4 zeros, 4 solutions, okay? Polynomial, I'm just going to say PLY for polynomial, with real coefficients, And here's the conditions, okay? -1, -1, and 3i are all zeros. Okay, now let me just talk to you about what we're going to do. We have got to find a polynomial that has the highest power of 4. So our highest power is x to the 4th, and I have given you 3 of the zeros. So I want you to use this concept right here that I gave you, that I told you is a star for your notes. The complex zeros always occur in conjugate pairs. And we're going to use these zeros that I gave you, we're going to turn them into factors, and then we're going to write a polynomial using all those concepts. So I'm going to write the zeros down again up here. I gave you 3 zeros. Because of the star statement that I gave you on the last page, you know that -3i is also a zero because all complex zeros will occur in conjugate pairs. So 3i and -3i are conjugate pairs. This was not given to you. You had to use that concept that I gave you and told you that complex zeros occur in conjugate pairs. Now what you're going to do is you're going to take these zeros and you're going to list them as factors. We're kind of going in reverse. If -1 is a zero, it had to have come from x plus 1 as a factor. Okay, now then we're going to write down another one because it says that it's a double root, so I'm going to write it down twice. And then I've got x minus 3i, and then I have x minus -3i, which is x plus 3i. Now, isn't that a product of factors? All of those are factors. They came from these zeros that we were given, this one that we concluded. Now what we have to do is write the polynomial. So if you've got 4 binomials and you want to get a polynomial, then just multiply them. This is the same thing as x plus 1 squared, so we're going to do square together double square on that one. Okay, and then we're going to go back and we're going to multiply these, and we know what happens when we multiply those. Okay, so that's x squared minus 9i squared, which really turns that into x squared plus 9. Now what you want to do at this point is you want to ask yourself if you have a polynomial. And no, you do not. Not yet. You don't have one yet, but you are very, very close. All you have to do is to distribute and you will have a polynomial. So I'm going to go to that next screen and I'm going to rearrange this. X squared plus 9, which is what we came up with, times x squared plus 2x plus 1. And I'm going to multiply that out, and the only way to do that is just distribute, 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 and then combine your like terms. Okay, so I've got x to the 4th plus 2x cubed plus x squared plus 9x squared plus 18x plus 9. Okay, now let's combine our like terms. That gives us x to the 4th. I've got 2x cubed, nothing to go with that. I've got an x squared and a 9x squared, which is going to give me a 10x squared. And then I have 18x plus 9. Now then, I have a polynomial whose zeros are -1 as a double root and 3i and -3i. So we took that, we used the concept, we put them into factors, and then we multiplied, and this gave us our answer. We also know how to take a zero and go backwards and get the factors. Okay, that's going to be part 1. And I'll continue in the next set.